energy available, in terms of the composition of utility load, in terms of regulatory climate, and in terms of physical facilities presently in place or under construction. All these factors are bound to affect the perception of the future and the selection of the most appropriate path to meet the future. One thing is certain, however, when we're talking about the future of the electric power industry, we're talking about an industry whose product is approaching, we're not talking about an industry whose product is approaching technical or economical obsolescence. To the contrary, we're talking about an industry whose product, a unique form of energy that has the very special advantages of flexibility, precision, and efficiency at the point of use that are unmatched by any other form of energy. We're talking about an industry whose product is gaining on its competitors in the marketplace. We're talking about an industry whose product has become the very lifeblood of our society. We're talking about an industry whose health and vigor have become essential prerequisites to the health and vigor of our society at large, in my own view. Truly, electricity is the wave of the future, and on the surface that would seem to be reason enough to be optimistic about our future. But we'd better temper that optimism with some realism. We all know the many problems that are confronting our industry today in the socio-political and in the institutional areas. The tragedy of nuclear power in the country in the wake of the 3 Mile Island incident. The interminable delays in the licensing of power supply facilities. The governmental red tape and the complexities of regulation. The enormous financial risk and uncertainties involved in building facilities needed for the future we project. We need to pause to assess the question, what if our forecasts are incorrect? If we have more capacity than we need at a given point, regulators, who incidentally do not have to project the future, will say with 20/20 hindsight that our projections were wrong. And they'll follow that with what for them is a logical extension of that thought, that the expenditures made for these provisions were imprudent expenditures. What will they say, though, if we do not have enough capacity? To be frank, I'm more than a little concerned. I'm concerned because so many power suppliers have been severely penalized for their failure to see the dramatic slowing of the economy that took place in recent years. Never mind that the economists didn't see it either. We didn't see it. We didn't see the associated slowdown in the rate of increase in the use of electricity, and the companies have been punished for it. I'm afraid that there's some who will react by making the opposite mistake of forecasting too little growth, or that what may be more likely, decide not to bet the financial future of their companies on forecasted growth and simply not build for the future. Such a course of action could also have terrible consequences. For the nation, it could mean an economy that is restrained because of insufficient electric energy, remembering again how important that energy is to this economy. And the power suppliers would also be chastised for their failure to plan adequately, and most likely would be penalized financially. Now, we have to meet this and other problems head-on as they appear. We need to build all of the flexibility we can into our planning strategies in order to be in the best position possible to deal with the future uncertainties as they arise. We need to learn from our past errors. The key word, I think, is flexibility. Flexibility to deal with those unanticipated events that can so abruptly change the future. Our past is rooted firmly in science and engineering, and I believe that science and engineering will remain the essential ingredients in the future. We have to find ways to shorten the planning cycle. I'm not talking about the long-range planning cycle. I'm talking about the time that it takes to build power plants. No longer can we afford the 10 to 15-year planning cycle. We have to find ways to build capacity quickly, perhaps in smaller increments, but to do so in a manner that doesn't sacrifice too much efficiency or too much economy. As new generating facilities need to be built to meet future load growth or to replace worn-out facilities, ways have to be found to do so in a manner that gives full recognition to the economic relationships, new technologies, new environmental requirements, and the growth patterns. As old generating facilities wear out, ways must be found to recycle them, to upgrade them. We can use some of this equipment for additional years of useful life. Our existing generating capacity is one of our best values. The availability performance of our generating capacity already in place needs to be improved to a level that's commensurate with the value of such improvements in terms of additional generating capacity that otherwise would need to be installed at current and much higher cost. The utilization of our transmission facilities as an integrating medium needs to be enhanced to the greatest extent possible, consistent with power system reliability and economy. And we also need to be concerned with load management. There are many things that can be done to improve our load factors, to allow us to use our existing systems to provide more energy without having to add to the existing systems. The communication and cooperation between the utility and its customers, our industrial, commercial, residential customers, needs to be enhanced in a manner that's commensurate with new technological advances as they occur, so as to improve the efficiency, the effectiveness, the economy, and the convenience of electric power utilization for the benefit both of the utility and its customers. All of this represents a tremendous challenge to the industry and to electric power engineers everywhere. Hand in hand with that challenge is another challenge that is confronting the electric utility industry, and every one of us as members of the engineering profession. It's a compelling need to improve our communications with all segments of our society. We simply must start where there is now little or no communication. We have to intensify that communication where it does exist. We have to be more imaginative than our critics in devising new ways to present the facts so that society can better judge our programs and our motives. Our business has always had a political overtone to it, but much more today than ever before. Truly, the economic aspects, the scientific aspects of our business all have been politicized, and we need to recognize that. I believe that as engineers that we have a moral responsibility to learn how to communicate. I don't believe that we can sit idly by when we hear others make unfounded and inaccurate statements, whether it be about nuclear energy, acid rain, transmission, or anything else, and simply remain politely quiet. If we don't know the facts as engineers, we need to learn them. We have a moral responsibility to speak out and correct inaccurate information that the public has. We should no longer let those uninformed zealots and politically motivated opponents have the center stage all to themselves. We need to learn to communicate effectively if we're to have an informed public. Engineers, electrical engineers, have to learn the art of communication. As engineers, we have truly invented the future of the past 100 years. Now we have the obligation to invent the future of the next 100 years by seeing that society understands and appreciates what we're doing in trying to accomplish, and that what we're doing is truly in the public's best interest, both in the short and the long term. Only if we can achieve that societal goal can we truly expect to make the contribution that we should make to the betterment of society. Thank you very much.
Well, thank you very much, gentlemen. I think first I would like to ask Mr. Gould if he has any further comments to make after having heard the other two talks, and then we will open the floor for discussion, but I hope we can do something about the lights because I can't see anything but these lights up here right now.
Herb, I don't think I have too many comments to make after hearing the other two speeches. I'd like to say that at the beginning I mentioned that every utility system would work this out, this problem of resources for the future, out to their own optimum purpose. And I think that my two colleagues have outlined exactly what they're doing there in that respect. What worked for us, I don't know that it'll work everywhere. I think I made that statement. In listening to Pete White, I was thinking, I don't know of any place in California where there's a single lump of coal burned for power generation, unless you consider this as an exception. There are one or two coal, or rather one or two cement manufacturers who commingle coal with their gypsum in order to make their final product, and they have waste heat generations, some of which is ours, some of which is theirs. That is, it's part of our cogeneration activity. But except for that, I don't know of any place where a lump of coal has been burned in California. The coal-fired plants that serve our system are outside of the boundaries of California. We operate one in the south point of Nevada, and we're a partner in one in New Mexico. So when Pete talks about his system being 80% coal, that's a luxury we don't have in our planning. When we talk about coal, we have to talk about doing something with it before we burn it, which we're doing at our gasification plant, where the impurities are going to be retained mostly in the slag of the gasification process. And I think that represents a distinct difference. If I lived and operated a system in the Appalachian region, coal would loom very large in my perspective, but you you operate the territory you have.
Thank you very much. Now we'll entertain some questions from the audience. If you would like to ask a question or make a comment, we would appreciate it if you would come to one of the four microphones that are in the aisles, and please identify yourself and your affiliation if you have a comment to make. Are there any? No? Well, here's one, and he is at microphone number 3, and that is Dr. Harder of Westinghouse, retired from Westinghouse Electric Corporation.
I don't need to identify myself. I've been identified. Mr. Gould, could you break down the 1,300 megawatts of alternate energy a little further than just the 1,300? Or tell us where that's available.
Actually, it is available, and I don't have the breakdown with me. I could send it to you if you'd like. I can tell you this, that the flagship of our fleet is cogeneration. That is, we didn't think it was when we started out, but it has become the flagship of the fleet. That is, there's more cogeneration than we ever dreamed of. There is geothermal. We would expect, well, we currently have about 60 megawatts. We would expect to get in the order of 200. But don't take these numbers as hard and fast, because I can give you a better breakdown. The wind, in this case, as you probably know, you install more nameplate capacity than what you receive on the line at any given time. And this amounts to several hundreds of megawatts that we expect to get from wind. We are in solar, we don't expect to get a great deal, but we are getting an awfully lot of favorable publicity on solar. We have solar both in thermal and in the cells, the solar cells, and we're currently installing a solar trough. But here again, we expect to get a token amount, but not a great deal. We're getting quite a little bit in small hydro. Having grown up as a hydro company, we passed up quite a number of hydro sites because they were too small. Fuel was $2 a barrel, and the transmission costs just wouldn't justify building the hydro, so we passed it up. We're going back now and filling in some of those blanks. We're also putting in quite a little bit of small hydro, we and others, third-party entrepreneurs, in places where there's an energy dissipation of water flowing for other purposes. So this is a qualitative answer. If you'd like to give me your card after the meeting, I would be happy to give you a complete breakdown.
Any other questions? Here's a Dr. Forsyth of Brookhaven National Laboratory at microphone number 1.
Notoriety at last. There's the sentiment that we should have plenty of research for the next 100 years has been expressed both at lunch and this afternoon. This is an activity of which I have a worm's eye view. And the honest truth is that in the past few years, the funding for research has gone down rather than up. And also, the emphasis has shifted from long-term to short-term, as exemplified by the superconducting generator at Westinghouse, cited in the award that Dr. Woodson got. That's been deleted by EPRI just recently. In the opinion of the panel, how much money should be in fact be devoted to research, say as a percentage of gross revenues for the utilities? How should it be got? And how should the long-range goals be set?
Fine. Who'd like to go first on that?
Well, as the immediate past chairman of EPRI, let me start. The pressures on research are these. The utilities, many of us, are very anxious to do more research. My own company does a lot of in-house research in addition to the support of EPRI. But there is this kind of thing happening. The regulatory bodies have put great pressure on utilities as far as their EPRI contributions are concerned. If you remember the genesis of EPRI, it grew out of perhaps this same situation that Pete referred to after the 64 or 65 blackout in the Northeast, when there was quite a bit of excitement and quite a bit of interest to see that we improved reliability. At the same time, there was a national movement to provide a national research laboratory that would be oriented toward electric power. The utilities went together and provided that laboratory through a subscription or a dues process whereby we created EPRI and supported it. And the net result was that we started out in the early years of EPRI with both a short-term horizon and a long-term horizon as far as projects were concerned. But as the years moved along and complacency set in, and I'm referring to complacency in the public and in the regulatory bodies, the pressures that worked against the research were these. First of all, cut down. Don't burden the ratepayer with any more than you have to. And make it practical. Make it useful today, which shortened the horizon. And very frankly, that's what happened to the superconducting generator, was the shortening of the horizon. So these are the things that are working there, and every year there's one more electric or one more regulatory commission that either restricts or eliminates the funding that some utility has been able to give to EPRI. And right now, the prospects of having that funding base increase are not too good as far as EPRI is concerned, and that's sad to say. But I personally believe that there should be a greater amount of research done than what's being done now in all sectors, short-term, long-term. And moreover, I think there should be research done as far as the end use is concerned. EPRI at one time wanted to do this. We talk about the rate of growth and the lockstep in which gross national product and electrical consumption have been. I happen to believe that there is a lot of potential for improving the efficiency of end use. And if this were done, we might reduce at least the ratio between GNP and electrical output, which would decrease the amount of capital that we would have to spend for expansion. These are random thoughts about research. Your basic question, the way you started, how much should be spent, I would say more. But Pete, do you want to?
Bill, I would respond in the same way. I don't think enough is being spent for research, but I think that, again, we have to recognize the realities. In our own company, we continue to carry on a program of research. It certainly is not as much as we would like. We have been research-minded over many, many years. But we have to recognize the political realities, and the political realities are that it's very difficult in the political climate in which we operate to look ahead more than about 2 years, which is about the time span that most people run for office. This does
right.
Definitely influence what we're able to do. We like to spend more on research. But we also recognize that we have a responsibility to share owners. Not only do we have a responsibility to the share owners, but we have to look to them to continue to invest in our business. And if we don't take care of our responsibility to them, they won't. So as much as we need to do research, we have to recognize the realities of the situation.
Herb, could I add just a word to that? You may be interested to know how we approach it in a practical budgeting process. We have a matrix that we keep evergreen. That is, we keep it up to date on about a 6-month interval. And if you can visualize having all of the research projects listed in a column and then have a calendar listed on the, what I will call the abscissa. What we do is we rank them, we force rank them, and we list them in order of importance, hierarchy of importance. This is the force ranking. And then we list them on how long it would take to do them and how much we can spend year to year. Then, after the rate cases have been determined and we know how much monies we have to spend on O&M and other things, including research and development, then we come down that list just as far as we can in its force ranking and take every project that we can possibly fund and we carry it forward. But we keep that list evergreen, and even though there are some that fail at funding, we don't drop them. We keep them in mind and keep them on our list.
And I might add a comment. The last time I saw a listing of the research projects at Southern California Edison Company, the number was 265 active research projects, and just really spanning the whole spectrum of possible things a utility could do to look to its future. And I was really impressed with that. Any other, well, just a question. At one time, your utility commission wouldn't even let you talk about load growth in the industrial area at one time or another. Are they letting you do end-use research these days and look at possible load growth?
Only cautiously, I would say. That is, we think we see a crack in the wall and that it's improving somewhat. In this regard, this might be a matter of interest to you. We currently have a little project going on in our part of the world to bring some realism into this matter of the heat pump. The high-efficiency heat pump is a very cost-effective device for end-use service in water heating and in air conditioning. And air conditioning and heating, that is the heat pump, the reversible heat heat pump for air conditioning and heating. And we're trying to conduct a campaign with our regulatory commissions to give that its justified position, because this improves load factor immensely, benefits the ratepayer and everything else. But there is a knee-jerk reaction among regulatory commissions that, well, if you encourage end-use devices that use electricity, particularly at a time when there's not a shortage of gas, you really impact the gas customer. Well, a gas customer is usually also an electric customer. And if you protect the gas customer in his gas pocketbook, you hurt him in the electric pocketbook. And we have something of a quiet campaign going on now, trying to bring some realism into that. Because if that were to occur, we could improve load factor, we could improve the use of the system, and even the rate structure in the electric system.
Are there any other questions? Would you come to the microphone, please? The gentleman at microphone number 1, please identify yourself and your affiliation.
Yeah. My name is Michael Wolf. I'm with the Bechtel Group of Companies. My question concerns the future alternative ownership of generating facilities. I was very taken with Mr. Gould's description of what I would characterize as enlightened relinquishment of ownership of renewable resources and alternative energy installations. But I'd like to move to the other end of the spectrum, and that is of the large centralized facilities. In particular, I think probably the most extreme case, that of nuclear. And I think that with the interregnum which we now have before us, we do have the time to plan for what could be a resurgence in the 90s or late 90s. And I think there the changing climate would suggest that an alternative approach would be necessary. And as you're probably aware, there was some consideration has been given to a kind of a government or quasi-government consortium for nuclear building ownership and operation. But I think that probably the climate and the ideological base of the nation would probably prefer something which would be more in the private sector. So my question basically would resolve around this, that how would you view, as chief executive officers, the possibility of a one or more, possibly one per reliability council area, major nuclear consortium, which would basically do everything. They would arrange for the operation of the fuel cycle, complete, including rad waste disposal, building of very well-designed, incorporating all the very best technical features in a standardized design, which would then be replicated. And the energy which would be obtained from these facilities would then be sold for subsequent transmission and distribution by the utilities of the nation.
Thank you. And I've even heard that described as a ComSat-like corporation in one or another forums. Mr. Gould?
Well, let me give you my view. I would start out immediately with one statement, and that is that nuclear power should not be built by people who are, well, I'm trying to find the words without offending. It shouldn't be built by the amateurs, let's say. In the early days of nuclear power, I think there were a lot of people who wanted to get into the nuclear club. It was a distinction. It was a status symbol. I think there were a number of nuclear plants that were started that should have been started with a different ownership or sponsorship basis. Now, I'm not being an elitist when I say that, but I think that there should be enough size and substance and financial strength behind the nuclear plant that they can carry it off. I think there should be enough engineering talent and enough operating experience that they can carry it off. So I would start there. Now, that is a foundation piece for my saying that a consortium is neither unusual, in my perspective, nor is it objectionable. The plant that we have, we're the sponsor. We own 75% of it. 20% is owned by San Diego Gas and Electric, and 5% is owned by small municipal utilities. So we do have a consortium, but we also have somebody who's in the nuclear business who has been there since 1957. We had a nuclear experience that early with a small generating station. But so I would start with that. A consortium isn't objectionable to me, nor is it unusual. There are a number of them. I don't think it needs the overlay of government sponsorship. I think I mentioned in my prepared remarks that we conduct exploration, mining, and milling of uranium. So we are on the front end of the fuel cycle. The only parts of the fuel cycle that we're not in are those that are reserved to the government, which are enrichment, and of course, the tail end, closing the tail end of it, the disposal. And those are reserved to the government. We don't fabricate it because the manufacturers have developed that technique far better than we could do if we tried to fabricate it. So in effect, we have something of what you have suggested. But I think your question goes a little deeper than just what has been done. It goes to what happens when the Renaissance comes in nuclear power. And I am one that believes the Renaissance in nuclear power is going to come. And I think that when it does come, certainly it should be built by those organizations or consortiums of organizations that have the financial strength, the engineering ability, and the construction ability to do it and do it right, and also have the experience to operate it. I think without question that's the centerpiece of the scenario for the Renaissance that I see. But there's one or two other things. I think that when we do this again, when the Renaissance comes, that we've got to be looking at some changes. Now, I'm not enough of a reactor engineer to tell you what they're going to be, but it is possible to build reactors that don't require the real snap decisions that 3 Mile Island required. It is possible to have this process just a little bit more stable and slow. I think that's one thing that has to be. I think we have to have a reactor system that, if you will, is not tender. I hesitate to get into details because it sounds as though I'm criticizing people's designs or their systems and things of that kind, but such things as the amount of stored water, the amount of heat sink that was had. 3 Mile Island could have been better in that regard. There are light water reactor plants that are better. And for that matter, I've always thought it was lamentable and regrettable that the gas-cooled reactor did not have an industrial base to back it up. Had the gas-cooled reactor been at 3 Mile Island, the operator could have gone home, had lunch, and maybe even a siesta, and come back and made his decision. But we are where we are. We developed the reactor industry on the technology that we had, which was light water, and the industrial base was built under it. We don't have an industrial base under the gas-cooled reactor, as desirable as it could be. But I think that there are going to be some changes that are required. Standardization is one of them. But when we blithely talk about standardization, remember this, that every plant that is standardized has to be sited. And the site has a peculiar geology of its own, and that is what makes a standardized plant difficult. If we could decouple a standardized plant from the earth to where we didn't have to make it site sensitive, then we could build it as a standardized unit. but those standardized units have some problems associated with them. Now, I've kind of wandered around in the wilderness of that question. Maybe I should stop and give Pete a chance on that.
Mr. White?
Well, Bill, I agree, first of all, with your point that when nuclear units are built again, that we're probably going to have a different design, one that I think, in your words, is less tender. And while I'm not a nuclear engineer either, our engineering people tell me that this can be done. I also agree that there will be a renaissance in nuclear. I don't think there's any question about it. I don't think the country will really have a choice. But I feel that that renaissance is going to be a number of years in coming. I don't think that anyone that has had experience with nuclear in recent years who's currently a chief executive officer, frankly, will have the stomach for starting a new nuclear plant at this point in time. So my guess is that we're talking about something after the turn of the century, perhaps. Philosophically, there is a question of whether or not there would be a government involvement in the ownership of new nuclear plants, or whether the governmental involvement is not necessary. Certainly the government is involved very much in the regulation, but not in the financial aspects of it, except in particular cases where they're in systems such as TVA where they're now operating. I think you could develop a philosophical argument about that right here in the room, perhaps. But I think the real question about, and as you point out, Bill, there are already consortiums that own nuclear plants where more than one company is involved. Somebody has to be responsible. And the real question is, where is the financial risk lie? When you're talking about a nuclear plant these days, you're talking about not millions of dollars, but perhaps billions. And when you begin to raise that kind of money, somebody has to take the risk. And if you're talking about a group of investors who want to build a nuclear plant and put their own money in and risk the fact that it will be given an operating license and will be operated and then sell the energy to a utility, that's one thing. But if you're talking about some kind of a take-or-pay contract in which a utility takes all the risk, I think that's an entirely different thing. Someone is going to have to stand up and take the risk. And if the utility takes those risks, it's going to want to have control of the situation.
I would agree.
Thank you very much. Do we have any more questions? Seeing no more. Here's one at microphone number 3.
I'm Jim Strother, and I'm chairman of the Education Subcommittee of the IEEE Energy Committee. And recently we have prepared a revised slide presentation titled Energy in Perspective, which was just approved by the IEEE Executive Committee yesterday. It's been prepared in conjunction with the Power Engineering Society, and a lot of the people who participate in that are here at this conference. We now have it produced in 400 sets. One set of slides, speaker's kit, and tape cassette is to be sent to each IEEE section to be used to indoctrinate the public on all energy matters. This slideshow goes all the way from 1850 to the year 2020, all the way from wood to fusion, including nuclear and breeder reactors and alternative energy. So my question really is, what is the best way to get it out to the public through the power utility companies? And are there any restrictions on individuals who may work for a power company making this presentation?
I don't know.
Who wants?
I know of no restrictions that we would impose on IEEE members who wanted to make that presentation.
We certainly wouldn't, Bill.
Okay? Real fine. Well, it is getting late in the afternoon. I would like to thank our speakers for a very, very stimulating session. Dr. Reese for the history, and Mr. Gould, Mr. White, and Mr. Austin for their most stimulating remarks. Let me once again advertise the IEEE Centennial Book, which is now available, and it's available at the room right outside the door. And let me ask Gib Berman if he has any, Gib, do you have any things you want to say? Fine, thank you, and thank you all for being an attentive audience.
As long as I can read what's going on. Yes, it is. We are. Thank you.